For our next presentation, we have Mr. Rob Porter with Sony Europe. And Rob's going to be talking to us about testing controllers for NMOS compliance, which is a very important topic nowadays because many different types of controllers are being put onto the market. We need to make sure that all of them are capable of working according to the full NMOS specification. So Rob, take it away.
Thanks for coming, everyone. Just a bit of background first. So a few weeks ago, there was an event called JT&M Tested, which took place at Riedel's headquarters in Wuppertal in Germany. And loads of different manufacturers from the industry got together to put their solutions, their IP solutions, through some tests so that they could get a badge to say they'd taken part in these tests, and also an entry in a catalogue that showed how their solutions complied with different standards and specifications from the industry. And that includes both the SMPTE ST2110 standards for the data plane for streaming video, audio, and metadata over IP networks, and also the NMOS specifications for the control layer for making connections between those devices. And for the first time at this JT&M Tested event, we introduced automated NMOS controller testing. I'll explain what we mean by that a bit later. And I want to tell you today about how we got to that point. So I'll start by going through the basics of what NMOS actually is, what we mean by an NMOS controller, what's the expected functionality of an NMOS controller, and the features it should support, what the NMOS testing tool is, and how we added controller testing to that, how you can use that tool yourself by downloading it from the internet and trying it out on your own premises, how it was used at the JT&M Tested event, and then what we're going to do next for controller testing in the future. So NMOS stands for the Networked Media Open Specifications, and these are specifications that are developed by the Advanced Media Workflow Association, or the AMWA for short, and they're a set of open APIs for managing devices on professional media networks. So as I mentioned, these are the kind of media networks you have in broadcast studios and OB trucks, for example, where we're streaming media flows between different devices using the SMPTE ST2110 set of standards typically. So we have video flows, audio flows, metadata flows across those networks. So those standards are very well defined for the data network, for the data plane of the network. For the control plane, we use the NMOS specifications to do things such as discover devices when they're first plugged into the network and be able to make connections between them. And the advantage of NMOS, one of the advantages is they're completely open specifications. They're available on the internet for free. You can download them from GitHub, you can look at them, and all manufacturers are attempting to comply with these specifications so that we have inter-vendor interoperability, meaning that we're not bound to proprietary standards and specifications. We're all using these open specifications so we can get true interoperability. The NMOS methods themselves use standard web-based technology, so we're sending messages over the network using RESTful APIs. So these are HTTP operations such as get, put, patch, delete, typically with JSON payloads that allow a bit more information to be transferred between devices. And if you want, that's a kind of asynchronous method. If you want to get updates when things change on the network, you can also use WebSocket technology, which is part of the NMOS specifications, to get notifications of updates when things change on other parts of the network. So you can see on the right there's a whole host of different NMOS specifications that are being developed, and as user requirements develop, these are being added to all the time. The two key ones that we're going to talk about today are ISO 4, discovery and registration, and ISO 5, connection management. So I'll now just explain the context of what we mean by an NMOS controller. So here's a very simple professional media network. At the center there, you can see a network switch. So this is all over a local area network. And at the bottom, you can see a couple of what we call nodes in NMOS terminology, NMOS nodes. And by that, we just mean a media endpoint on the network whose job it is to either send or receive media flows on that network. Then the registry, this is something that was introduced for NMOS particularly. This is something that contains a database of all the different nodes on the network. That's sometimes called an ISO4 registry or a registration and discovery system. And the controller you can see at the top there, the idea of that is it allows you to get a view of everything that's in that registry, all those different nodes, and make connections between them using the NMOS specifications. So that's what the NMOS controller is. In the context of ISO4, those nodes, when they're first attached to the network, they make themselves, they make everything else on the network aware of their presence by first discovering the registry on the network and then using the ISO4 registration API to add themselves to that registry's database. And then the controller's job is to use the ISO4 query API to find out about all those nodes on the network and be able to add them to the controller's user interface. And then where it really gets interesting is the controller can then make connections between those nodes on the network to actually basically do the routing on your IP media network. And to do that, using its list of nodes that it's already got, it can choose to talk to the sending node first using the ISO5 connection API. It can configure that sending node and then grab a set of transport parameters from that node, usually in the form of an SDP file, and it can then patch that same SDP file on the receiving node that it wants to make the connection to. The receiving node can then get itself in the right state to receive the flow from the sending node and join the appropriate multicast group to make the network technology work, so the flow, the media flow can flow from the sending node to the receiving node there. So in order to allow manufacturers to make sure their NMOS solutions are working properly, AMWA a few years ago set about creating something called the NMOS Testing Tool. And this has been collaboratively developed by various different AMWA members, manufacturers, broadcasters, and others. And it's something that's freely available on the AMWA GitHub site as open source software, so you can see all the source code. It's all written in Python. You can edit it, you can comment on it, you can make pull requests or log issues if you think it's not working properly. It's all developed completely in the open. And the idea is that it ensures that anyone's professional media solutions can conform to the NMOS specifications correctly by allowing those users, those manufacturers, whoever wants to try it out, systems integrators, to self-test their equipment. So you can download the testing tool from GitHub and try out all these tests yourself. We then have things like the JTNM test event that I just mentioned at the start of the talk, where manufacturers can bring their solutions to this event. They can get a badge saying they've taken part and a catalog entry saying which parts of the different standards and specifications they comply with. And at the JTNM test events, to do all the NMOS testing, they use the same NMOS testing tool that you can download and try out yourself in advance. And as you can understand from all of this, these are key tools to drive better interoperability in the industry. If everyone can make sure they pass the test in the testing tool, they can, everyone's devices can talk to each other, and we should have really nice, easy deployments. System integrators have a very easy job getting everyone's equipment to talk to each other and work when they do customer deployments. So that's the end goal of all of this, is this better interoperability. So I'll now kind of talk about what the NMOS testing tool was originally like before we added controller testing. So it focused mainly on testing NMOS nodes and registries originally. And these are kind of usually devices that you don't need a user interface to drive them once they're in operation. They're running alone. So it's quite easy to, or relatively easy to develop a tool that can talk to them automatically and run through a set of tests. So if we have an NMOS node under test on our network, such as a camera that's a sending node, what you might do as an operator is then download and spin up the NMOS testing tool on that network. Once it's running, you run this Python script to get it running. You get a web interface, and you can configure that web interface to point at the node API that your NMOS node is offering, and then you can also configure your NMOS node to make sure it understands that the NMOS testing tool is running, and that for example, the DNS services on that network are now provided by that testing tool. So once it's all up and running, you set the tool going, and it spins up some other NMOS resources on the network. So to test a node, what it does is it spins up some mock registries. It's then the NMOS node's job to do various things. So once it detects the registry on the network, it should register with it. So the NMOS testing tool is able to automatically detect that those API commands over the network are being received by the registry, and the node is registering itself with the correct registry. That would be the one that's set up with the highest priority. It can also do things like take one of the registries down and make sure that failover works, that if the node was registered with that registry, it will then re-register with one of the other registries in that set of mock registries. As well as testing that the NMOS node is sending out these correct ISO4 registration API commands, it also has to check that it can correctly respond to ISO4 node API and those ISO5 connection API commands that I showed you earlier that the NMOS controller would be sending. So in this case, the NMOS testing tool is sending those API requests to the node and making sure it gets the right responses. And by doing this and running through a whole host of different tests, the testing tool is able to come up with a set of passes and fails for that NMOS node. And this is how nodes were tested at JTNM Tested recently, as I mentioned. So controllers are a bit of a different game, because in this case, controllers are user operated. So you don't just put your controller on the network and leave it there. You have to operate it through a user interface. So previously, when controllers were tested at an earlier JTNM tested event, it was actually done manually via a testing team who had to manually get the manufacturer to show them how they operated the controller and kind of check off the tests one by one. And it was a quite laborious and time-consuming process, quite expensive as well in terms of that time. So what we set about to do at Sony, we proposed to automate this controller testing. We set up a new AMWA activity and got various other manufacturers and broadcasters to join that activity. And we set about creating a controller test suite using a slightly different approach. So again, you run it through the same NMOS testing tool. It's exactly the same download from GitHub. And you configure that to set it up on your network. In this case, it's not just setting up registries, it's setting up some mock nodes as well, because we want to test that the controller can make connections between nodes. But the really new part is that we have this NMOS controller testing facade. And this allows the testing tool to send various questions to the facade and get answers from it. And the facade is basically instructing the user to carry out various things, various operations on their controller's UI, and then checking that those are carried out correctly. And I'll give you a little demo of that in a moment. So the operator will configure and operate their NMOS controller under test via its user interface. The controller will do some of those operations I showed you in the diagrams earlier on, like query the registry for all the nodes that are on the network, make connections between nodes on the network, and the testing tool is able to make sure that those commands are all correct and validate those. The operator then answers various questions that the testing facade poses it, like what different nodes can you see on the network? Can you see that a connection's been made between these different devices, that kind of thing. And the operator answers those questions, and then the NMOS testing tool via the Q&A protocol is able to ensure that those questions have been correctly answered. So the testing tool is validating the whole operation in two ways. It's checking the query API and connection API operations are being carried out correctly by the controller using this green line at the bottom, and it's also checking the answers provided by the operator are correct using the green Q&A protocol line at the top there. So it's not 100% fully automated. That would be difficult when you've got a user interface, although you can, for a particular manufacturer's controller, you could have a kind of robot interface to operate that UI if you can understand the type of tests that are being carried out. And we did prototype something like that. But for general use, you need to have the operator involved carrying out the instructions. So it's kind of semi-automated controller testing. So on the next slide, I'm going to show you a kind of very brief demo of this. So on the left, you'll see the NMOS controller testing facade. And on the right, you'll see Readle's open source or freeware, I should say, Readle Explorer, which is a nice kind of controller that you can download and use for free. And we thought this was a good one to test the testing tool with because it's out there available for other people to use for free as well. So if I just go to the demo slide now. So on the left here, you can see the testing facade. It's giving the user some instructions. It's asking them to see which of those different sending nodes in the list the user can see on the controller's UI. The user's then checking that UI, and the user can then select from the drop-down from the different checkboxes there which of those senders it could see on the UI. They select those, they submit the results. So this is just one test out of many that are available in the test suite. And once the results have been submitted, they get a nice page on the testing tool that tells them which tests they passed and which they failed. In this case, they passed all the tests. So that's a very short kind of summary of what the tool's like to use in practice. So if you want to try it out yourself, it's freely available, as I mentioned. It's available on the specs.amwa.tv webpage. There it's got full instructions of how to use it. If you'd like a walkthrough of how to use it, my colleague Jonathan Thorpe at Sony, along with Gareth Sylvester Bradley from NVIDIA, have created a nice video, which I believe is linked to from the AMWA website, but you can also find it by searching for NMOS Test Tool tutorial on YouTube. And that will walk you through how to set up the testing tool and how to run it. So I've mentioned a bit about JTNM Tester already. So this automated or semi-automated controller testing was used at the most recent JTNM Tested event for NMOS controller testing. Going back through the history of JTNM Tested, the original event back in March 2019, we were only doing data plane testing, so only testing the SMPTE ST2110 video, audio, and metadata flows on the network. In August 19, some NMOS node testing was added using the NMOS testing tool. And then in March 2020, which was a virtual event due to the onset of the pandemic, they did add some NMOS registry testing, again using the testing tool. But the controller testing, which was done at that event, was done manually, as I mentioned. So now we've got fully automated, or at least semi-automated in the case of controller testing, testing for all NMOS nodes, registries, and controllers at the most recent event back in August. So what's next for controller testing? Well, just to kind of reiterate first how we got here. Back in, I think, May last year in 2021, that was when we at Sony proposed the NMOS client testing activity. We got a bunch of other people from AMWA involved. We had that approved by the AMWA Board of Directors as a new activity. And we set ourselves a 4-month time frame basically to produce enough tests in that client testing test suite to do the same kind of tests that were previously done manually at JTNM Tested. And we delivered that back in September 2021. It then went through a period of review by the NMOS Architecture Review Group, and then they approved that test suite after a few minor amendments early the following year, whereupon we hosted an AMWA workshop in March 2022, we invited participants to come and join us to prepare themselves for a potential JTNN tested event later in the year. And at that event, they were able to try out the NMOS testing tool, both for node and registry testing, and to try out the new controller test suite and make sure it was fit for purpose. And then, as I've gone over already, in August 2022, we had the JTNN tested event, and now, September 2022, I believe the catalogues for JTNN tested were published just yesterday, and there'll be other talks on this stand later at this event where Evgen, who was in charge of JTNN tested, where he'll be able to go through some of the results with you, take you through the catalogues and how things worked out. And I think Gerard from Arista is going to talk about the network that was used at JTNN tested later this afternoon as well. So there's a few more talks about that event later on the IP showcase. And then the second row of events at the bottom there is more about what we're going to do next for controller testing. So in parallel to the client testing, the controller testing test suite being reviewed, we started a new activity. Again, Sony proposed and led this activity, and this was called the NMOS controller specification activity. And what we realized was that the wording about controllers in some of the NMOS specs, such as ISO 4 and ISO 5, sometimes it wasn't entirely clear what functionality you needed to support as a NMOS controller manufacturer. Sometimes the word client was used, sometimes the word controller was used. So what we did is we pulled out all the spec language about controllers and made it crystal clear by creating new controller sections in the ISO 4 and ISO 5 specifications, as well as in the BCP 00301, Natalie named security specification, which is all about adding transport layer security to your network using HTTPS instead of HTTP commands, basically. And those three new patch releases of those specifications were published just at the beginning of this month, in fact, on the 1st of September. So they're available to look at now. And what we're going to do now is review those and check whether the testing tool we've created covers all those use cases already, or whether we need to create some more test cases for some of the language in those specification updates. And just to give you a brief look at what those new controller sections look like, there they are on the specs.amwa.tv website. You can see the ISO 4, ISO 5, and the security spec there on the left. And as well as that, to kind of draw all that controller functionality together and give you a nice starting point if you're a controller manufacturer or you just want to understand more about NMOS controllers, we created an NMOS controller implementation guide that you can see on the right there. It's called Info 005. That was also published on 1st of September and talks about what we expect from controllers and links to all those new sections of the other specs. During the controller specification activity, we also reviewed all those other NMOS specifications you saw in the list, and it might be that in future those also get their own dedicated controller sections. So that's where we are today. Please do let me know if you have any questions. Thank you.
So do we have any questions for Rob? Okay, not seeing any, so thank you very much.